All right, getting into chapter 7 now. So this will be the first half of chapter 7, worksheet A. So just going on down the list of assigned problems, we're going to start off with number 1. So now we're getting into some basics of calculus. So differentiate, that can also say find the derivative, same thing. So just to differentiate something like that, notice all those are already nicely broken up into separate terms for us. So we just go on down the line and do one term at a time. So anytime you see a constant, those always go away within the derivative. So think of that as 2x to the 0 power. So when you use the power rule, that 0 causes the whole term to zero out. So we just move on to the next term. So 3x to the third, just using our power rule. So we're looking at 3 times 3 gives us 27. Sorry, 3 times 3 gives us 9. And then we do our exponent minus 1. So 9x squared. Jump on down to this next term. 5 times 4 gives us 20. Drop our exponent by 1. And there's our derivative. So pretty simple there for number 1. So we're going to move on down now to number 11. So anytime we have something like this where it's not in friendly format like the one that we just did, we want everything laid out nice and separated like that. No fractions like this one is. So we're going to rewrite that into friendlier terms. So I'm going to separate the 1/4. And I'm going to take that x and move it up to the top, so it's going to become x to the -1. And now it's in a better format, so now we can do our power rule. So I've multiplied that -1 times that 1/4, and I get -1/4. And then if I subtract 1 from my exponent, we're down to -2. So that's what our derivative would look like. Of course, you can put the x on bottom, but that's only necessary if the directions specifically say to do that. If it doesn't say, then you could leave it in this format. But if I wanted to take the x and put it back on bottom next to the 4, I could write it in that format right there. So either way is acceptable unless the directions say otherwise. So moving on to number 13. So greatest and least values of y within that given domain from 1 to 4 inclusive. So with something like this, so greatest and least or max and min, same thing, always occurs whenever your derivative is 0. So I'm going to take the derivative of our function, slide that one over. So using the power rule, we'd be looking at 3x squared minus 27. That's our derivative. I'm going to set that equal to 0. That's where all of your max and mins occur, or greatest and least values occur. So if we solve that equation, so add the 27, divide by 3, so x squared equals 9, which means x equals plus or minus 3. So those can be maxes and mins. In this case right here, it's saying least values of y, so we need to plug those back in to get those. One thing to consider, though, is look at our domain. I'm only looking at x's between 1 and 4, which means the -3 is out. So I'm only going to use the 3 to get one of my answers here. I can't use the -3. So if I plug the 3 back into my original equation to get the y value, so I'd be looking at 3 to the third, which is 27, minus 27 times 3, which is 81. And then if I subtract, so 27 minus 81 is -54. So that's got to be one of our answers. So let's just consider some other values within the area, just so we can pick out the biggest and smallest numbers. Remember, I'm only going from 1 to 4 inclusive, so we're also going to, let me just remind us where we found this one from. So that was from where x was 3. So let's test a couple other kind of boundary limits on this one. So if we were to plug in a 1 into the original equation here, so 1 minus 27 is -26. If I were to plug in the 4, so 4 to the third, so we plugged in the 4 to the third gave us 64. Minus 27 times 4, which was 108. So subtract that, and we're going to come out with -44. So within the numbers that we're testing in here, we can see this is our our lowest. And this, remember, this has to be a max or a min because we set the derivative equal to 0. So that always creates a max or a min value. In this case, we can tell by the other numbers around it that this has to be the minimum. So that's our minimum value, and then within this domain of the numbers, we kind of tested the extremes on this and came out with negative 26 as the highest within that domain. So that's going to be our max for this guy. And you could always take the time to throw that into your graphing calculator, and if you look at the graph, it would be even more obvious that this is the highest point within that domain, and you'll be able to see this is the lowest point within that domain as well. All right, so moving into number 14, equation of the normal. One thing to keep in mind is the word normal always means perpendicular. So that's a huge key vocab word. So normal means perpendicular. Oftentimes, students mistake the word tangent for the word perpendicular, and that's just not the case. So the word normal is what would tell you that it's perpendicular. Tangent, a point of tangency, just means they share a common point. Has nothing to do with parallel or perpendicular. So in this case, the equation of the curve, so remember the equation, we're always thinking of like y equals mx plus b. So we usually use our point slope process to figure that stuff out. So the point of tangency is point P, and those are the coordinates of that point. So we want the perpendicular line at that point. So to do this, to get point and slope, we already have the point. We just need our slope. So that's always where your derivative comes in. So if we take that function and find its derivative, so in this case, using our power rule, would give us negative 2x to the first. So there's our derivative. If we want the slope at that point, we just sub in the x coordinate in order to get our slope. So in this case, if we did negative 2 times a fourth, we'd be looking at negative 1/2. So that's the slope. In this case, we want the perpendicular slope. So we're going to flip that and change the sign to positive 2. So now we have our point and our slope. And now we can just go ahead with our point slope process. So I'm going to do y minus the y coordinate over x minus the x coordinate. And we tend to do point slope a little different than this, but this is the way it occurs in our formula packet. So this is the way I'll write it for you. And they call it the gradient function for this. So in this case, I got to set it equal to the slope that we have. And so that's our setup. Now we just need to do a little bit of cleanup here. So we're going to take this denominator and multiply it over to the other side, which is really the way we would tend to write it anyway, that you probably learned it in the past. So as we would tend to write it like this. So the formula they use kind of takes an extra step to get to this step. So anyway, we're going to distribute the 2 on this and continue to get y by itself. So if I distribute the 2, so I got the 2x minus 1/2. I'm going to add that 15/16 over. And of course that could be done in your calculator and still maintain the fraction. Or you can just, create common denominators. If you think of this as 8 over 16, so negative 8 over 16 plus 15 over 16 would give you 7 over 16. Remember, just formatting is really important on this. So if the directions didn't say otherwise on a test, this would be an accepted answer. There's other formats you could write, but usually these come with some set of directions on how to write your answer. This one really didn't, but this is something you really want to check for on a test question to see how they want the answer formatted. Sometimes they will ask you to put everything onto one side, so they might ask you for this, which just means get everything onto one side. Sometimes they'll keep C on the right, so they might say write it in the form of like this right here, which we would call standard form that you've probably learned in the past. Sometimes they will say keep all your variables as elements of the integer system. so which means no fractions. And so if you see something like this, that means don't leave any fractions in your answer. If you didn't see this, then you can leave fractions. So it's really important that you kind of just check your directions on this and make sure you follow proper formats. So in this case, I'm going to go with one of those formats just because those are pretty popular ways of writing it. Let's even take an extra step and clear out the fractions, just because that can occur on a test as well. So if I were to take everything and move it over all the way over to the left, so I'm going to put my x first, then my y, then my constant. So that's a popular format. If you were to see something like this, that means they want integers only and no fractions. So I would have to multiply the entire equation by 16 in order to make that happen. So I would get the negative 32x plus 16y minus 7. And so that's just another way of writing it. So again, really important that you check directions on a test. We could even multiply through by -1 and change all the signs, and that would be another way of writing it. So both those answers would be accepted if we did something like that. So a lot of different ways we could write that answer, just check directions. So moving on to 19. Alright, so here we got a curve. They're calling it curve C, giving us equations. So first part of this is just asking us to find the derivative. That's what that notation is asking us to do. So looks like we got a little chain rule on this one. So really important, with this one, you really have two options. I could just FOIL this and do 3 minus 2x times 3 minus 2x, FOIL, or double distribute, however you want to say it, and then do the power rule from there, and that works. That would be an option. Another way to do it, though, is chain rule, and this is something that we really want to be good at because it plays a big part in a lot of future chapters, and it's often a weak area for people. So this is good review of the chain rule right here. So doing the derivative, just like the power rule, I want to multiply my exponent to the front. I want to subtract 1 from my exponent, but this is the step that a lot of people forget, is when you're doing chain rule, you then multiply by the derivative of the interior function. So what you see in parentheses is the interior function, and the derivative of 3 minus 2x is just -2. Because remember, constants go away. If I apply the power rule for that term, then the derivative of that term is just -2. And so because this is chain rule, I always want to remember to multiply by the derivative of the interior function. Really a commonly missed step on this process. So I can now take that -2, multiply it to the front, and get -4 times 3 minus 2x to the first. So there's our derivative. So the coordinates of the point C, which the gradient or the slope of the normal is -1/8. So in this case, they're saying the gradient of the normal is this, which means if I were to flip that, I would get the one that is parallel. So +8 is the parallel slope. So for this guy, I can now set my derivative equal to 8 to get the x coordinate. So just keep in mind that parallel slopes are equal, so which is why we want to work with the parallel slope, not the perpendicular slope on this. So I want to know where the derivative is equal to something. So in this case, it's equal to 8 since parallel slopes are equal. Now I can solve that equation for x. So divide the -4, you got -2. Subtract 3, you got -5. -5 divided by -2 is 5/2. So we have our x coordinate. And then I can just always plug that back into the original function to get a y coordinate. So if I plug that back in to get the y coordinate, that's where you're going to come out with your value of 4 for your y value. Moving on down to number 20. So for this function, evaluate the derivative where x is 4. So this just means plug a 4 into the derivative function. Again, this is about putting things into friendly terms. So think of that as x to the 1/2 power, which means the derivative, if I use the power rule where I multiply my exponent to the front, if I subtract 1 from 1/2, that would bring me down to -1/2. Since I'm going to be plugging a number into that, you could do all that in your calculator and that's fine. But you should always know how to do some of this without a calculator as well, because there's definitely going to be a need for that. So to plug a 4 in, I would probably want to put it back into radical form. That's probably easier for most students to work with. So I could think of this again as it's a 1/2 power, so that's like a square root. Because it's negative, it goes on bottom. So another way to write this would be like this. And that would be the same thing. Now it's probably easier to plug in that 4. So we know the square root of 4 is 2 times 2 gives me 1/4 for that answer. So jump down to 23. So equation of the normal to the curve, and we've seen something like this already, so I'll keep it quick. Just keep in mind normal means perpendicular. Really important that we understand that. Whenever you're finding the equation of a line, we're just using our point-slope process. We already know the point. Oftentimes they don't give you x and y. Maybe they just give you x and you got to plug that in here to get the y coordinate. Maybe they just give you y and you plug that in for y and solve for x. So sometimes that can be kind of the initial steps on this, but we know x and y. So in this case, I'm going to find my derivative. So I got 3x squared is my derivative. If I plug in a 1, so 3 times 1 squared is 3, which means the perpendicular slope is -1/3. And now we can use our point slope process now that we have our point and our slope. So we can do y minus the y coordinate over x minus the x coordinate equals our slope. In this case, let me do a little cleanup here. So that's y plus 1. Whatever's easiest for you at this point, you could cross multiply and multiply your 3 over to here, multiply this over to the -1. Whatever makes sense for you at this point. Just to solve it correctly, I'm just going to bring over my x minus 1 like I did before. And again, it's at this point you would just want to check directions. This didn't say anything specific for how to write the answer, so I'm just going to keep it basic for now, because we already kind of went through all that in the earlier problem. If you didn't watch the earlier problem, it would be a really good idea to watch it, the one that was similar to this, just because I went over the different formats and some of the directions that you can see on a test question. So that's always important. So in this case, let's subtract 1. So 1/3 minus 1 would give you -2/3. And again, so this would be acceptable for this problem because the directions don't give me another format to write it in. If you needed to, you could multiply the entire equation by 3 to get rid of your fractions. If the directions said something about keeping everything as elements of the integer system, that's what you would want to do. But again, so just follow directions on how to format from here. Moving on, 24. So coordinates of the point. So now they're telling me that the tangent is parallel to that line right there. We already know that parallel lines means they have the same slope. So since the slope of that line is 9, that means the slope of our line is 9. Whenever working with slopes, that automatically means derivatives. So in fact, in any word problem, you can replace the word gradient with the word derivative. So in this case, we have the derivative, which is 2x plus 3. So remember, if the derivative equals something, that means the gradient equals something. And in this case, the gradient is 9. So if we just solve that equation, so subtract the 3 and divide, we have our x coordinate. In this one, sometimes they just say find the x coordinate or solve for x. We would be done. This one says find the coordinate, so we need a y value to go with it. So remember, anytime you're looking for a y value, that's going to come from the original function. So I'm going to take my 3 and plug it in. So 9 plus 9 would give me 18. And now I have the coordinates of the point. So moving on to 25. So starting off with a function given there, we're using something called the first principles method on this. So on 25, so evaluate for where h is, you can see this is approaching 0. It's getting super small. So it's kind of like what's the value that we're using to get this if h is approaching 0. First principles method is really how derivatives were formed. So this is where they come from, is this process. we're not really required to know the first principles method, so we sort of skip this and just go straight into derivatives. But if you took a calculus class or something like that, they would teach you the first principles method first and then go into derivatives from there. So it's a good background for where derivatives come from. So this would be the same thing as if we were to say, what's the derivative where x is 6? It's a lot quicker. Instead of doing this process for this, we would just take our derivative and plug in a 6 and get our answer that way. But this would yield the same result. But anyway, if I just follow this process, so I'm going to replace my x with 6 plus h. So there's that, and then minus f of 6, so 6 squared is 36. And we're just keeping that over h. So if we did a little cleanup, so you got some FOIL to do on that. So if we did that FOIL process, so 36 plus 12h plus h squared minus 36 all over h. You can see on this my 36's would cancel. I can divide an h out of each term, and that brings me all the way down to just 12 plus h. So now if I were to sub in my 0.001, you could see that we would just get 12.001. So what is this approaching? So this is the idea of a limit. So the limit that we are approaching as h approaches 0 would be 12. Think about it as you made this value smaller and smaller and smaller, you get closer and closer and closer to 12 as your answer. So the limit that we are approaching is 12 as h approaches 0. And you can see if h were 0, we would have 12. And so that's the whole idea of the derivative that I mentioned earlier. If you just took the derivative, you would have 2x. And if you plugged in a 6 for x, you'd have 2 times 6, which is 12, which is where those derivatives come from, is this process. So anyway, moving on to 27. All right, 27, differentiate. I know I should be using the product rule on this because I have two separate terms. They both contain x's, and we are multiplying. So I know this is our product rule, so we're going to do the first term times the derivative of the second term. Derivative of this set of parentheses would just be 6x squared plus the second term times the derivative of the first, and derivative of e to the x is e to the x. And so that's what we have right there. That would be an accepted answer if you wanted to leave it like that. Sometimes for formatting purposes they may ask you to factor out a common term, which is usually the way that you see the answer written. These both have e to the x in them. So oftentimes you'll see it where they factor out the common term and would be written this way. So that's just another way of writing the answer, but either one would be accepted because the directions didn't say otherwise about how to format your answer. One thing I really want you to keep in mind on this is you have to recognize when to use the power rule, or sorry, the product rule. So the product rule is used anytime you are multiplying two terms and they both contain x's and we're trying to do a derivative. So that's when the product rule needs to get used. So moving on, last two. So 28, and just like you got to recognize when to use the product rule, you also have to recognize when to use the quotient rule. So the quotient rule is used whenever you are dividing and both terms contain x's. So on this one, just follow me. We got the formula for this in the formula packet if you ever forget. So we have the bottom term times the derivative of the top minus the top times the derivative of the bottom. Derivative of that would just be 3x squared over the denominator squared. So that's what we got right here. You try to clean things up if possible. It's not like mandatory that you'd have to even go farther. That would be an accepted answer on an IB test. It would be to leave it right here. But if the directions said to clean up something further, then we would need to do that. Oops, and I forgot my exponent. So like on this one, within all these x's, you know, we could factor out x to the third. So that would be an option. If we did that, if I were to distribute the 4 that's left over, I would have my 4x to the third minus 4. And then over here, if I took an x to the third out as well, this would become x to the first times this would give me 3x to the third. Notice now I'm allowed to combine those because I have 4x to the third minus 3x to the third, which is 1x to the third. So x to the third minus 4 over the bottom squared. So there's another way, there's another way that we could write that answer. But again, this would have been an accepted answer on a test unless the directions say specifically to format it somehow like this. And so they might word it that way somehow, but again, it's all about reading directions on a test and make sure you follow those really clearly. So here's the last one. So in this case, they're giving us a setup of a function without any real values in it. Obviously, I'm right off the bat, I'm thinking quotient rule because it's set up as a fraction with 2 different functions. And so they're giving us a few things right here. So find the equation of the normal to the graph where x equals 3. So keep something in mind on this. If it's the equation of a line, remember we're just thinking point slope, so I need a point and a slope. And so those are kind of the 3 pieces that we got to come up with. So my point would be, let's just start with the x coordinate. And in this one, we know x is already 3, so that's something we could plug in. Where do we get the y coordinate? Always comes from the original function. So if I take my 3 and I sub it back into the g function, I know the result would be 24 for the numerator. And if I plug 3 into the h function, you can see right here that that would give me 6 as my answer in the denominator, which means if I reduce, I have my y coordinate. And so again, that was just kind of plugging 3's back into those functions, and they just told me what those would yield as far as their answers go. So now we have our y coordinate. Now we just need a slope. Remember, slope would just come from the derivative. So, and in this case, it's the whole quotient rule. So I have the low times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And so they gave us all that information. We just got to plug in the numbers. So we already know h of 3 was 6. The derivative of the g function of 3 right here was 8. And then the original g of 3 was 24. And the derivative of the h was 3. The original h, again, was 6. So 6 squared gives us our denominator. So we just got to do a little cleanup on that. So if we did a little cleanup on that, looks like we get negative 2/3. Really careful that we read on this one that we are looking for the normal, so I need to use positive 3/2 as my slope. But now I can go through with my point slope process. Now I got all my key information, so now we're back to basic point slope on this. So y minus y over x minus x equals the gradient that we want to work with. And now we just, again, repeat the same process that we did earlier to put it into a proper format for an answer. Go through that real quick. So from here, bring in that x minus 3 over. This could be a good state, so just multiply everything by 2 and clear out the fraction on that if you want. That can be done at any time, so oops, I'm going to run out of room there, so there we go. So 3x minus 9. And again, this is just about formatting from here, so we could bring everything over to the left. So I would have negative 3x plus 2y, add the 9. So that's one way to write it. Maybe you want to put the 1 on the right, and it would be negative 1. Looks like the answer maybe on the worked out solution is different, but I don't think they took into account that this is supposed to be the normal. Looks like they just stuck with the negative 2/3 as their fraction when they should have flipped it like we did. So it should have been 3/2. So the answer should come out looking like the one I'm showing you here.